Hello friends, in this video we will see gain of in this workshop we will see gain of differential amplifier. So we will see how to size these devices. Gain is given by GMN ROP parallel RON. Okay. This transconductance is we can find out using say by bandwidths. FUGB is given by GMN 2 pi CL. So we will see regarding this. For time being, assume FUGB is some value, and from that we can find out our transconductance. Then another thing is ROP and RON. So RO is given by lambda ID. So here ID is IT by 2. In this branch IT by 2. Now we know ID, we need to find out what is lambda. So for finding lambda, lambda actually depends upon function of length. So you can say RO is function of length. So RO directly proportional to length of device. So we plot ID versus VDS curve. This is VDS, this is ID for N and PMOS both, and this is linear region, this is saturation region. So because we are biasing these devices say in saturation region, so what we will do, we will take now 2 points here and we find out before that so ID is given by beta factor, can be N or P. So this is mu n COX W by L 1 by 2. Okay. VGS minus VT square, VT is threshold voltage, 1 plus lambda VDS. Okay. So for two values, say ID1, ID2, VDS1, VDS2. Okay. So basically this slope, if we reduce this slope, then RO is increasing. If we increase this slope, RO is reducing, and this depend upon length. So here length is increasing, RO increasing. Now so we can put this value ID1 upon ID2 equals to 1 plus lambda VDS1, 1 plus lambda VDS2. For different lengths we can find out different lambdas, and accordingly we can find out output resistance of devices. So if we are going to increase length, RO will increase. So using this for N and PMOS, we can find out different lambda for different lengths. So we can change length, say initially we can take 1 micro, then 2 micro, then 4 micro length. For all these we can find out lambda, and we can find out RO, output resistance. Using this experiment for both N and PMOS, we can find out RO, and using bandwidth we can find out GM. And now another thing is we know GM. Now using bandwidth, now we need to find out output resistance. With this experiment we find out our output resistance. So say we say RON equals to ROP equals to RO. So gain is GMN RO by 2. So now we have GMN, and we need to decide length, which depends upon output resistance. So from here we find out length, and now from bandwidth we find out GMN, and GMN is 2 ID nu n or nu p COX nu n. So this is NMOS time into W by L of NMOS. Okay. Now ID is IT tail current divided by 2, so this will be IT tail current mu n cox W by L n. Okay, from here from output resistance we find out length. So now we are having length, and so from here we find out ratio of W by Ln. Say some ratio comes say 4, and say length from output resistance is coming 2 micro, so W will come as a 4 into 2 equals to 8 micro. So for NMOS, W by Ln is 8 micro by 2 micro. Okay, and say from this experiment we find out say length for PMOS also 2 micro. Okay, now we find out size of this NMOS and length of PMOS. Now this is current mirror, so if we are going to do Monte Carlo simulation where we want less offset, what we will do, we will take W by L ratio less, so that we are having less mismatch in this current mirror. So W by LP should be less, and so that we have less mismatch in this current mirror, and this W by L should be large. So minimum we have decided 8 by 2, and for mismatch purpose this WL by should be large, so we can take it more than 8 by 2 micro, so that we have less mismatch between these two devices. So it will give us whatever gain we are decided more than that, and good bandwidth and less offset or less mismatch between devices. So in this way we can find out or we can do sizing of differential amplifier. So this is basic idea how to do biasing of how to do sizing of differential amplifier. But now there is one case, we want ICMR equals to say ICMR plus equals to VDD. So it means its VGS should be equals to threshold voltage, so that we can get ICMR VDD. For that purpose we need its bigger size, W by L ratio should be large. So in that case we need to take bigger W by L. But for offset reduction and mismatch between these two devices, we need less W by L ratio, so that impact of threshold voltage mismatch will be less, because if VGS minus VT is high, then if VGS is high as compared to VT, so any mismatch delta in VT has less effect, and if VT is close to VGS, then effect of VT mismatch, any variation in VT will be more. So so there is trade-off in these two things, and if we are taking less W by L, then V on voltage for this PMOS is high, so output range from higher side also reduce. So overall there is trade-off between different parameters. You have to give priority which specification you need to achieve. Okay, so accordingly you have to decide sizing. And bias current depend upon power consumption, so you need to also decide what is the power consumption you want. Accordingly you need to decide this tail bias current. Okay, so here we have seen how to size different devices in differential amplifier. Thank you.